Welcome everyone to my presentation on the underrepresentation of women in computer science, a literature review. The agenda for this presentation can be seen below. It's in 8 steps, and let's begin. So let me start by introducing this subject and present my research question. So astronomer Clifford Stoll once said, the first time you do something it's science, the second time it's engineering, and the third time is just being a technician. I doubt anyone would doubt the impact of technology in the modern world. For example, how much technology have you just used today? From checking an app to changing the temperature to playing a game, and the youth of today are the mass consumers of new technology. We live in an age that has access to more information than at any other time in human history. But is more really better? A lot of information could be just considered garbage. M.C. Escher, the artist, once said, "We adore chaos because we love to produce order." Sorting through garbage and making something meaningful as a task is what technology can really do better, and I would argue that the pursuit of computer science takes information garbage and transforms it into information order. However, the people creating or serving new technology often do not meet the needs of the new consumers or the new youth of today. There can be a disconnect from what people want to consume, from what they want to be served. So with technology, the youth can stay that consumer on the outside or become part of it from the inside. So it's an important subject in our modern education system. Despite this, it has several challenges. For example, computer science education is part of most major universities, and although it is an option course in Canadian provincial high school education, it is not available in every high school. In the late 1990s, while working in the software development industry, I reflected on becoming a teacher. I had previously completed a Bachelor of Arts with a history major and a minor in philosophy, and then took my computer science major with a mathematics minor, and spent most of the late 1980s and the early 1990s as a post-secondary student, and then went on to complete a Bachelor of Education, where I have worked as a teacher of computer science for the last 23 years. I want to make sure that my passion for computer science came across in the connections and relationships I made with my students. This shaped the early philosophy I had as a teacher, which I describe myself as a warm demander, pushing for results while maintaining a contact. Okay. Over time, this would evolve into more authentic assessment, effective engagement, and from a philosophical position, more of a reductionist and an objectionist, because I consider sense, perception, and reason as fundamental ways of knowing in my teaching philosophies. Formulating all of my years of experience into my current teaching philosophy matches with something I often say to students, which is, solving problems is how we learn. I strongly believe that teaching is not only about delivering subject content, but also on guiding and helping students on how to solve problems by equipping them with the tools to do so. I will use this personal teaching philosophy of myself to shape my perspectives as I approach the following literature review. However, this literature review will not be based on opinion, but instead on a critical examination of research data and the conclusions they drew, arguing for the need to examine the underrepresentation of women in the field and study of computer science. Now, having established the importance of computer science as a subject and my personal connection to it with the anecdotal experience and the initial research, it drives forward my initial and primary research question, which is there a problem with the underrepresentation of women in high school and post-secondary computer science programs by enrollment data comparatively to men? Let's begin. From that primary research problem, several supplementary research questions tangentially related to that main research question came forward. Is the hypothesis that women are underrepresented actually true? Is there a correlation between high school and post-secondary computer science programs? Do women have the same sense of belonging? And is this a question of why discrepancies are occurring? And most importantly, what can be done to affect change? Let's discuss the terms of the research and the literature review and the methodology behind it. So let's start with the terms computer science. The etymology of the word computer, or compute, comes from the Latin words come, to come together, and putere, to settle an account. So the early versions of the word were about settling financial accounts. The first time they used the words computers in the more modern sense was applied to people. People were the computers who did the calculations. Around 1946, the computer was first applied to a device. In the picture you see here, it was the computer room. Mostly women doing the mathematical calculations at the time for important research organizations like NASA in the United States. Now the word computer is an umbrella term encompassing many different aspects of technology. Now, the word science traces its etymology all the way back to a Latin word which essentially meant what is known, or it was originally synonymous with the word knowledge. So, putting these concepts together, I could interpret the two words to mean people who do calculations and know things. Obviously, the term and the phrase has evolved. From a more modern perspective, computer science is both a theoretical academic subject taught in high school and university programs, and it's also a practical, concrete, or vocational job in software development, software engineering, programming, etc. But to me, when I often define the terms computer science to students, I define it as step-by-step problem solving on a computer using code. Now, the term underrepresented will be defined in the numerical data, which will show a lower percentage of representation in institution enrollment data comparatively to those who do not identify as women. The term post-secondary will mean those data sets from those students who have graduated high school and are now registered in college and university, whereas the word high school will be similar, but for grades 9 to 12 in public and private schools. And finally, the most contestable term, the term women, will not address a sex versus gender debate, but instead use it in terms of gender and those who self-identify as women to be part of that particular in-group. During the initial phase of the literature review, it was search criteria that was used, like, are women underrepresented in computer science programs? Are there correlations between high school and university programs? Do women have a sense of belonging? What is the value of stereotypes and role models? All that initial research turned up over 50 articles around those central themes. And first level elimination was for those that were over a decade older than current research, in addition to those that fell outside the parameters of the established problem. Then, moving from this sort of priority order into from alpha order into priority order, what I did was I put the articles into a Google Scholar library, exported them into a spreadsheet, and then once into Microsoft Excel, I used Visual Basic for Applications to write a custom sorting algorithm to look for patterns of words and frequency of words in the various abstracts and the various conclusions of the articles. From there, I was able to organize them into that priority order using conditional formatting to create a heat map to allow me to examine which articles were more relevant and less relevant to my topic. And that's what went into my methodology for this literature review. The first piece of the literature review developed some themes, 4 main sectional themes. The first was to prove the hypothesis. Were women actually underrepresented? 5 different research articles supported a proof that that hypothesis was in fact true. Some of the figures, some of the data sources presented are shown here in graph and table format. Each of those added a different dynamic to prove that hypothesis. It showed enrollment and graduation rates proved the hypothesis. AP high school data, enrollment data comparatively to other majors, declining enrollment over time, and attrition rates. All of this followed that the initial claim was shown to be warranted and that the research literature backed that claim in a strong qualitative data-driven argument. This can even be shown in a Toulmin argument structure, where the claim that women are underrepresented qualified by that this will likely be statistically lower on the grounds that the post-secondary and high school data would show this less representation, warranted by my personal anecdotal data, and backed by observation and the strong research and data sources I drew up, Of course, a rebuttal that this is not an underrepresentation and that there were other mitigating circumstances will be addressed further into this presentation. All right, the next theme that came up in the literature review was the expectations and antecedents of this causation of underrepresentation. Okay, so when examining these student female expectations, that sense of belonging, perceptions of performance, prior experience with computer science, all formed a functional positive or negative antecedent to registration in computer science programs. Simply put, this addressed the why question. Why was this occurring? Why were women underrepresented? So from this and from further review of the literature, several different causal elements appeared. A reduced sense of belonging, perception of academic exclusion by fellow students, self-efficacy beliefs, perceptions of individual performance potential, growth mindset, poor advisement about computer science as a major, lack of computer science experience, lack of exposure to programming, and the quality of the instructors in computer science. The next thing that came up, role models and stereotypes, was definitely related in the sense that it was an additional precursor, a predictor, not only of initial enrollment, but also of attrition. More specifically, role models had a positive influence, and the negative connotation of stereotypes had a negative influence on research, on enrollment in computer science programs and retention. Supplementing that previous theme on expectations, these negative influences and positive influences can be another definite antecedent factor, whether they are retained. And it can be connected as well to the other ones, the feelings of belonging and self-efficacy outlined in the previous themes as causal factors addressing that why question. Now the literature review moved forward from identifying that the problem is established and identifying some causation to that problem. It now looked at the next steps in the literature review and what the literature was proposing as ways to address this problem. So it led to multiple dynamics of influencing belonging, and it addressed many ways to move forward. For example, one article stated, our findings point to as few possible one-size-fits-all remedies to improve women's persistence in computer science, including the encouragement of more evidence-based instructional techniques, as well as increased support for contingent faculty members who typically teach introductory computer science courses in research universities. The literature also made 6 strong recommendations to incorporate computer science into provincial or state standards, to make computer science a core subject, to designate computer science as a high-need subject, to recruit and prepare diverse computer science teachers, to create clear pathways for computer science teachers, to train teachers in cultural competencies, particularly STEM teachers. And this directly leads forward to my personal limitations and recommendations from this literature review. From a limitation standpoint, several limitations have to be acknowledged. That the vast majority of the literature review did not originate in Canada, which could indicate a regional bias not applicable to Canadian schools. There is definitely an assumption that underrepresentation could instead be misinterpreted from an intentional gender segregation, for example, a female computer science class, designated for that purpose. And a lack of feeling of belonging is a very difficult thing to gauge. Any survey data that could measure this lack of belonging could have something like a loaded question fallacy that could be a definite limitation to the data I've presented. Gender biases, of course, come forward that could have affected the interpretation of this reviewed literature and the conclusions drawn from them. The recommendations moves into 3 general categories and more specific categories under those. The first is that computer science should be acknowledged as a core subject, a provincially mandated graduation requirement in modern education and not just an option course. The second recommendation would include, but not limited to, individual classroom changes like ensuring curricula and assessments are gender relevant, ensuring that school administrators and student services accurately describe computer science courses, to create a culture of belonging and reduce stereotypes within the computer science classroom, to explore more evidence-based instructional techniques like paired programming, and to recognize women's accomplishments as both mentors and role models, and to really put forward the idea of good teachers in the computer science classroom. The third and final recommendation is to propositionally put forward the design of further experimental research on this problem. This could include more general and widespread data beyond post-secondary programming, to include data sets from even primary and middle school along with secondary schools. All right, let's move on to a final discussion and a final conclusion. The primary research problem that I hypothesized in this presentation, that the underrepresentation of women in high school and post-secondary computer science programs by enrollment data comparatively to men, this hypothesis was shown to be both true and significant. The causes of this problem were examined to include things like female expectations, lack of belonging, prior knowledge, role models, and stereotypes. The next steps and the recommendations moving forward to address this problem were put forward. But in more simpler vocabulary, computer science programs are not attracting enough women because many women do not feel they belong in a computer science classroom for a variety of reasons, and we need to act to change this. The meta-analysis of this critical research done in this review, and having taught computer science for over 20 years, adds to the validity of these connections presented. I would argue that this extensive experience in computer science education that I have, and my lengthy career of encouraging female mentorship and female participation, would also further validate these conclusions. The final message put forth is that although underrepresentation of women in computer science education is a problem, it is not a problem we can afford to ignore. Thank you.